7 visitors from the edge of the void are hurtling towards our sun. While that sounds like the opening of a sci-fi blockbuster, it's a snapshot of the constant traffic passing through our cosmic neighborhood. In late 2024 and into 2025, a lineup of comets is set to light up our skies, including one that astronomers are whispering could be the comet of the century. Is this just a spectacular coincidence, or is our ability to scan the cosmos revealing a sky far more active than we ever imagined? Let's explore this together. The digital sky watchers. How do we even find these cosmic nomads before they arrive? Forget the image of a lone astronomer. Today, the hunt is run by a silent, relentless network of robotic telescopes. Surveys like Pan-STARRS, the Zwicky Transient Facility, and the Catalina Sky Survey are the world's digital eyes. The ZTF's camera, with its 47-square-degree field of view, scans the entire northern sky every 2 nights, generating about 1 terabyte of data each night. This fire hose of information is piped to processing centers where sophisticated algorithms sift through billions of objects, looking for faint, moving targets. When a candidate is flagged, its position is sent to the Minor Planet Center, the global clearinghouse directed by Dr. Matthew Holman. This triggers a global race among professional and amateur astronomers to perform follow-up observations to confirm the object and calculate its orbit. This system has revolutionized the game. As of 2024, these surveys have collectively discovered several thousand comets. This digital dragnet ensures that very little gets by, but as lead ATLAS astronomer Dr. Larry Deneau notes, the challenge shifts from finding comets to understanding them, especially predicting which ones will put on a show. 7 against the odds. So, what are the chances of seeing a truly spectacular comet? Astronomers joke that the universe is stingy. The models that predict comet populations, like those from Dr. Harold Levison, show that the confluence of a perfect orbit and a large active nucleus is incredibly rare. Most great comets are first-time visitors from the Oort cloud, a theoretical sphere of trillions of icy bodies named after Jan Oort, stretching an immense 100,000 astronomical units from our sun. For every comet Hale-Bopp with its 60-kilometer nucleus, there's a comet Kohoutek from 1973. Hyped as the comet of the century, it fizzled dramatically, teaching astronomers a hard lesson about the unpredictability of these icy bodies. As the legendary comet hunter David Levy once noted, "Comets are like cats. They have tails, and they do precisely what they want." Statistical analyses suggest a Hale-Bopp-class event occurs perhaps once every few centuries. The odds for a bright naked-eye comet are better, maybe one every 5 to 10 years, but many of those are poorly positioned for viewing. This is what makes the buzz around C-2023 A3 so palpable. It's a genuine contender that could defy the odds. The quiet visitors. What about the comets that don't make the headlines? For every potential superstar, there are dozens of faint visitors that are scientific goldmines. Take 67P Churyumov-Gerasimenko, target of the Rosetta mission. Up close, Rosetta, guided by Dr. Matt Taylor, revealed a world of jets and organic molecules. The Philae lander found a surprisingly hard, non-porous surface. Critically, Rosetta's measurements showed that 67P's water had a deuterium-to-hydrogen ratio 3 times that of Earth's oceans, complicating the theory that comets delivered our water. Another key example is Comet Wild 2, visited by NASA's Stardust mission. The mission, led by Dr. Donald Brownlee, returned actual samples to Earth in 2006. In a stunning twist, analysis of these samples revealed high-temperature minerals like olivine, which can only form very close to a star. Finding this material in a comet born in the deep freeze of the outer solar system proved that there was dramatic radial mixing in the early solar nebula, completely rewriting our models of how the solar system was built. These quiet visitors provide the ground truth that underpins all of planetary science. The crowd pleasers. Every now and then, a comet arrives that's destined for the spotlight. In 2020, it was Comet Neowise with its 5-kilometer nucleus. Now, all eyes are on C/2023 A3 Tsuchinshan ATLAS. Discovered on January 9, 2023, it's on an 80,000-year orbit that will take it to a perihelion of 0.39 astronomical units. Forecast models by Dr. Quanzi Ye suggest it could reach a magnitude of 0 or even brighter, thanks to powerful forward scattering of sunlight. For context, another great comet, Hyakutake in 1996, passed a mere 15 million kilometers from Earth, revealing a stunningly long ion tail that stretched over 100 degrees across the sky. While Tsuchinshan ATLAS won't pass that close to Earth, its intrinsic activity could be very high, with some estimates suggesting a dust production rate of thousands of kilograms per second near the Sun. If it holds together through the intense solar heating, a major uncertainty for any first-time visitor, it could develop a brilliant tail visible even from light-polluted cities, becoming a true generational celestial event that inspires millions to look up. Spacecraft Symphony. While we wait to see these comets, a fleet of spacecraft has a front-row seat. SOHO's LASCO coronagraph has discovered over 4,000 comets, mostly Kreutz sun grazers that vaporize, but our modern fleet is even more capable. The Parker Solar Probe with its Whisper imager can see the fine structure in comet tails as they are sculpted by the solar wind. In 2022, Solar Orbiter, in a study led by Dr. Geraint Jones, passed through the tail of Comet Leonard, directly sampling its particles and the embedded magnetic field, which measured a few dozen nanoteslas. As Dr. Carl Badams from the Naval Research Laboratory explains, these spacecraft use comets as natural tracers. Watching a comet's tail disconnect is a direct visualization of a solar storm, a plasma cloud that could later impact Earth. This provides invaluable data for space weather forecasting. This direct sampling is revolutionary. It allows scientists to distinguish between isotopes and measure chemical abundances with a precision that is simply impossible to obtain from millions of kilometers away on Earth. The 6-month marathon. The arrival of a great comet isn't a single night's event, it's a marathon. For C/2023 A3, the show unfolds over months. For most of early 2024 it was a faint target, brightening from magnitude +12 to +10. The real action begins around its September 27, 2024, perihelion, the danger zone where tidal forces and thermal stress are at their peak. Its closest approach to Earth comes around October 12, 2024, at a distance of about 71 million kilometers. Throughout this journey, thousands of observations from amateurs provide a continuous light curve, a plot of its brightness over time. This data, often compiled by organizations like the Association of Lunar and Planetary Observers or ALPO, is crucial for spotting sudden outbursts or signs of fading. Citizen scientists like Terry Lovejoy, who has discovered 6 comets, play a vital role in this global effort. The compressed schedule turns the sky into a living laboratory, a story that unfolds night after night, with data from around the world painting a complete picture of the comet's behavior. Tales of two tails. When you see a picture of a brilliant comet, you're often looking at two different tails. The broad curved dust tail is made of micron to millimeter-sized grains pushed by sunlight. The curvature is determined by a factor called beta, which is the ratio of radiation pressure to gravity. Larger particles have a smaller beta and stick closer to the orbit, while smaller particles are pushed away more dramatically. Now, the other tail is the ion tail, shining with an eerie blue light from fluorescing carbon monoxide ions. It's made of gas grabbed by the solar wind, a phenomenon first theorized by Ludwig Biermann and confirmed by the Mariner 2 spacecraft in 1962. Sometimes a third antitail can appear. This is actually an optical illusion seen when Earth crosses the comet's orbital plane, as famously observed with Comet Errand-Roland in 1957. The larger dust particles left in the orbit can appear to point towards the Sun from our perspective, creating a striking spiky feature. Each tail is a unique physical laboratory, telling a different story about the comet and the forces acting upon it. When solar storms strike. A comet's tail isn't just a passive trail, it's honestly a battleground. The Sun sometimes unleashes a coronal mass ejection or CME, which is a billion-ton cloud of plasma. On April 20, 2007, Stereo A watched a CME slam into Comet Encke. As analyzed by heliophysicists like Dr. Angelos Vourlidas, the footage showed the comet's ion tail being sliced clean off by magnetic reconnection. This happens when the CME's magnetic field lines snap and explosively reconnect, releasing immense energy. A fast CME can travel from the Sun to Earth's orbit in as little as 15 hours, moving at over 2,000 kilometers per second. This isn't rare. Comet C2011L4, or Pan-STARRS, also experienced a dramatic disconnection in 2013. These events provide a unique, large-scale plasma laboratory, allowing scientists to witness physics impossible to replicate on Earth. Seeing a tail disconnect is a visual proxy for a plasma cloud that could later impact our planet, providing a beautiful, if a bit ominous, early warning of potential geomagnetic storms. The interstellar outlier. Perhaps the most profound discovery is that our solar system, well, actually has visitors from other stars. In 2017, 1I/Oumuamua was detected, a bizarre object 400 meters long but perhaps only 40 meters wide. Its slight, non-gravitational acceleration led Dr. Avi Loeb to propose it was an extraterrestrial artifact, though a leading natural explanation from scientists like Dr. Jennifer Bergner is that it was outgassing invisible hydrogen. Another compelling theory from Alan Jackson and Stephen Desch suggests it was a nitrogen iceberg fragment chipped off a Pluto-like exoplanet. Then in 2019 came 2I/Borisov. Observations analyzed by Dr. Dennis Bodowitz revealed it had a carbon monoxide to water ratio at least 6 times higher than any comet from our Oort cloud. The Vera C. Rubin Observatory with its 3.2 gigapixel camera is expected to find dozens more of these objects once it begins its legacy survey of space and time. This will transform interstellar studies from, a novelty into a statistical science, giving us a sample of the building blocks of planets from countless other star systems. Windows to wonder. So, how can you see the next great comet for yourself? For C2023, A3 Tsuchinshan ATLAS, the key dates are in late 2024. The best viewing window is predicted to be from roughly October 12th to the 20th. It will appear in the evening sky, visible in the west about 60 to 90 minutes after sunset. Use an app like Stellarium to pinpoint its location as it moves from Virgo toward Serpens Caput. Give your eyes at least 15 minutes to adjust. And try using averted vision, looking slightly to the side of the comet. This uses the more light-sensitive rod cells in your peripheral vision, making faint objects appear brighter. For those wanting to take a picture, a DSLR camera on a tripod is all you need. Using a standard lens, try an exposure of 10 to 15 seconds at an ISO of 1600 or 3200 to capture both the comet and the background stars. As veteran observer John E. Bortle would advise, brightness predictions are notoriously difficult. The goal is to go out and look, regardless of the final outcome, to witness a rare and beautiful cosmic event. The sky is more alive than we ever knew. The constant parade of comets, from the quiet visitors to the interstellar outliers, is a powerful reminder that our solar system is not an isolated island, but a dynamic and connected part of the galaxy. Whether a comet like Tsuchinshan ATLAS becomes a spectacle for the ages or not, the journey of discovery continues. The digital eyes of our automated surveys are always watching, ensuring that the next cosmic surprise won't be missed. We live in a golden age of astronomy, where the next profound discovery could be waiting in a single pixel of light, a traveler from the void bringing new clues about our place in the cosmos. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe. Thank you for watching Space Facts.